Dear colleagues, the topic of our work is investigation of failure mechanism of aluminum oxide ceramic specimen subjected to 3-point bending test. We have prepared the ceramic specimens by the sintering of aluminum oxide powder at 1600 degrees centigrade. The slide demonstrates the edge fracture surface, the pore size distribution and grain size. In the slide you can see the principal loading scheme as well as real experimental setup. Figure 3 illustrates as received loading diagrams of 6 specimens and final experimental fracture patterns. In order to simulate the deformation and fracture process of the material under consideration, we utilize the modified Rooker-Prager criterion with non-associated flow rule. Usage of non-associated flow rule is dictated by the more accurate description of dilatant behavior of material. One of the effective ways is to take the strength parameters of the material to uniaxial loading, namely the UCS and UTS. It is quite convenient to use the two-dimensional Westergaard stress space for representation of yield and phase transformation surface. The points for UCS and UTS in that case will be located as plotted in the graph. If we connect these 2 points with the line, then we will get the yield surface, and using formulas A and AB calculate the values of model parameters, namely the internal friction factor and cohesion. UCS and UTS have been recently obtained from the mesoscale simulation. Figure 5 demonstrates the convergence test and mesh refinement in the fracture process zone and near the supports. Figure 6 illustrates the comparison of the numerical simulation data and experimental results. Figure 7 illustrates the stages of crack propagation as well as change of maximum principal stress orientation axis. Table 1 summarizes all physical mechanical properties used in simulation. Thank you for your attention.